All right, what's up? It's time. I feel like that's not maybe the best way to start a lecture. It's your boy. You know who it is. Time to time to learn about JavaScript. All right. Hey, it's another beautiful day. It is. What day is it today? It's Tuesday. What week is this right now? Yeah, it's week 2, day 2. Too fast, too furious. Yeah, just straight out of the window. Things are gonna get wild today. We're gonna see. This is very much like a sequel, like movie or sequel lecture, where things feel familiar, but then there's something slightly different, and you're like, wait a sec, that character, I've seen them before. And then there's a bit of a twist. If I was to break this lecture down into acts, Act 1, things are good. Things are good. You're maybe feeling pretty good off of the end of last week. You got some good steam. Act 2, there's a new kid in town. All right, this kid looks like that. Probably got dark glasses, got headphones, walking around with a longboard. There's a new kid in town, right? And yeah, this new kid brings in a little bit of conflict. Act 3, we learn to work with the new kid. Who, interestingly enough, doesn't seem that different from the rest of the kids in town. And not only that, this new kid, though, has some extra special powers that helps us save the town from the monsters. So welcome to my TED Talk. Today, today we're going to be talking about something that you've already kind of seen before. So you spent the past week talking about asynchronous control flow, semaphores, mutexes, correct? No? I'm kidding. You did not talk about that stuff. But you're going to see that with async control flow, a lot of the ideas that I'm going to be playing around with today are not new. I'm just using old tools to do funky stuff. Before we really even break into what that is going to mean for us, I'm going to do a little bit of review. I know I asked this question last time I lectured, but what is JavaScript? What is this thing? It's on the tip of your tongue. Oh, no, not a... OK. What is JavaScript? Or JavaScript, as it's more commonly known. What is it? It's a computer language, a programming language. Right? And this programming language is going to be made up of lots of things. I'm pretty sure when we met up last time for lecture, we went through a list of the stuff that exists in JavaScript, and we made a list such as there's booleans, right? There are strings. You want numbers? We got numbers, right? These things are free. You can use these anytime you want. Case in point, I'll hop into Node. You want 1? You got 1. You want 1,000? You got 1,000. You can use these anytime you want. And they're going to be useful for particular, different things. One of the most interesting values for me in JavaScript is going to be objects. Objects. So today's lecture is not about objects, like at all. You will have lectures that are specifically around the ins and outs of how to work with objects in like interesting ways. But I did want to take like 5 to 10 minutes at the beginning of the lecture just to review objects, because I find that objects are one of the sticky points in JavaScript. Whether or not you have previous like programming experience, objects in JavaScript can be a little frustrating sometimes. So I wanted to take, again, some time out of the lecture, just out of context. We're going to talk about objects a little bit. Who here loves objects? Well, has nobody gotten like a curly brace tattoo on their their arm yet? No. Yeah. So objects are great. They help us do a lot of things in JavaScript. They solve some particularly neat problems. I'm going to say that objects are good for collecting stuff. Generally, anytime we want to remember something in JavaScript, right, we can make a variable. So if I want to remember a particular number, like, oh, don't forget 722, just don't forget it, I can go, OK, well, const number to remember is 722. Right? And if anybody ever asks me, OK, well, what is that number to remember? I go, hey, it was 722 because I've got it written down. Right? Programming languages are just very extreme note-taking. Just very extreme. I've got a number to remember. I might have other things to remember, such as, I'm going to say JavaScript here, such as maybe I want to remember a name, const name to remember is, and I might have a name like Joe Stefanina. Okay? So now I've got some name that I want to remember, and it's collected there. If I had a lot of these different things to remember, right, it might be nice to collect them all into one place and just say, hey, here are all the things that I need to remember so that I can pass them around as one. Right? Instead of telling someone, hey, here's the number to remember, here's the name to remember, and here's the, let's say, the food to remember. I can't remember how to write broccoli. Broccoli. Yeah? Yeah, all right. Broccoli. I don't eat vegetables. Here's like the 3 different things to remember. Instead of telling someone, hey, here's the number to remember, here's the name to remember, and here's the food to remember, I would like to give somebody, hey, here are all the things to remember, right? All at once, right? So you can handle just all those things as opposed to needing to like have so many different things all over the place. They're just collected into one nice package. Right? That is the construct that we use, objects, to be able to collect that stuff. Now, I find that people maybe intuitively get the idea of objects pretty early on. You've been working with them for the past week. But it's the syntax where people tend to get stuck. So we're just going to pass through the syntax, make sure we're comfortable with that, and then we'll move on. So we'll start off by saying that I want to create an object. Right? This is going to be like a cheat sheet style thing. How do I create an empty object? Say I wanted to make an object called things to remember. What do I have to type to do that? Cool. Equal to the what? Oh, squiggle brackets, right? So this here is an empty object. Right? It's fine. Empty object, empty collection, there's nothing in there yet. Right? I can also make objects that already have stuff in there already. So this was my empty version, but say that I want to make an object that has stuff in it already. What do I do? Pardon? I add stuff between the brackets. And what does the syntax in here look like? Say I want to say, OK, number is going to be 722. Cool. So it's going to be made up of a key and a value. What's the key here? number. Okay. And then how do I associate this with a value? It's going to be a full colon, right? Colon. What? Travis is making like angry eyes at me. So number and then colon. So number, colon, and then the value that I want to associate here is a 722. Right? And if I wanted to list a bunch of these things, what am I going to do? I have a comma, and then I can have as many of these as I want. So here's name, which is going to be Joe Stefanina, and then food, which is going to be broccoli. Right? So this is the creation of an object. The creation of an object can be pretty straightforward because you see everything here all at once, and you can associate these things. You go, OK, well, I see the word number, and that points to 722. And if I ever wanted to use the value 722, so getting a value from an object. So if I wanted to get the value 722 out of things to remember, how do I do that? Pardon? I can use dot notation. So what's that going to look like? Right. So if I want to call the number, then I go a number. Right. And this is fine. This is legal. This is great. I can say things to remember, and then specifically, I want the number from within there. Right. I want to go deeper in. Now, the reason that I want to really lay in on this is because there's two different ways of doing object syntax. Right. You've seen these two different ways, and even deep into the program, I see people mixing them up all the time. Right. The most important way to interact with an object is with the square bracket notation. Right? I highly recommend starting off by getting really, really comfortable with the square bracket notation, because the square bracket notation is one situation where it says, hey, you have an object, then you put square brackets, and then what do you put inside of the square brackets? It has to be a string. Like the values that you put within square brackets have to be a string. Right? So I can go number like this. This is legal. But I cannot go number like that. At the moment, there's no value called number. There's no variable anywhere declared being called number. So it won't know what this is supposed to be. It'll actually just get an error. So if we remember the fact that when we deal with objects, we have to use strings as keys, you're going to have a good time. You can completely forget about the dot notation. If it's confusing to you, completely forget the dot notation. Right? Because the nice thing about the square bracket notation is that if I have const key equals, and it's food, then I can go things to remember food. Right? And now I'm not getting, key. Saw everyone's eyes just go yeah, key. I'm not asking for the key in the object. I'm asking for whatever key is, which is food. I want to use that as the key in the object. Right? So you can do absolutely everything with objects using square bracket notation. Right? And if you find yourself getting confused with objects, my recommendation for you is to ditch the dot notation. Just get rid of it. Forget it, and then come back to it when you feel comfortable working with just square brackets. Right? In other programming languages, they only have one syntax for working with objects. Right? So some programming languages might say, hey, you know what? You can only do square brackets. JavaScript just thought it would be fancy and add in a second notation, right? But it ends up becoming confusing for people. So that's about as much as I wanted to say about objects right now. But I wanted to put that on your map, is that you don't need to use dot notation. Right? Come talk to me if you want more help with objects. I'm more than happy to show you how to work with nested objects and all that. This is not part of today's lecture, but do come talk to me if that's something that you want to see more about. But if you want to leave this part of the lecture with something, it's just use square brackets. Right? Minimize the amount of choice that you have. Right? Are there any questions about this at the moment? Cool. So the entire purpose of today's lecture is to work with async control flow. Asynchronous control flow. Now, with async control flow, we're going to do a couple different little demos over the course of the lecture. In the first little bit, what I'm going to do is I'm going to get you to motivate the idea behind why we need to solve this problem in a particular way. What async control flow even means. May have already read about it a little bit. But yeah, we're going to do mostly like a thought exercise. So let's start off by writing some imaginary code, and then we'll actually run it. Use my imaginary code. Console.log. Console.log. Welcome to Chili's. It's chili with, huh? No, like the restaurant. Yeah. Is sure. Welcome to Chili. What can I get you? All right. So welcome to Chili. What can I get you? And I might make an order. So I might go order, some imaginary order function. And what do they eat? I've never even been to Chili's. What are they, or in Chile in general? What is some Chilean food? Chili? All right, I will get some chili. Ordered chili, and how many orders of chili are we gonna make? Probably like 9,999. You know what? Let's throw another couple nines on here, just for fun. Why not? This is a lot of chili. This is gonna take a while, maybe a minute. I don't know. It's gonna take a little while, and then I'm gonna console.log. Cool. We'll be ready soon. Maybe not super soon. That's a lot of chili to order. And then I might want to go do something else, like maybe sit down. Okay, so this is some imaginary code. Welcome to Chili. What can I get you? I order this ludicrous number. What is this? 9 million, almost 10 million orders of chili. And then I get told, okay, it'll be ready soon, and then I sit down. Okay. Now, if I was to rename this maybe to order and make, order and prepare, what is your intuition about how this function would run? Or not this function, but rather this script, right? What's your intuition about how this stuff would happen? Mm-hmm.
So I assume the console log, like who will be ready soon, runs before that function ends, because that 10 million, like we have 10 million chili,
Mm-hmm.
right? And then probably that console log is gonna run before the end.
Mm-hmm. So we probably want that to happen, right? Like, for example, like I would want to sit down before the chili is finished being prepared, right? Like I don't order and then I just wait and wait and wait and wait, and then the chili's ready. I'm like, oh, my legs, thanks, and I sit down. I would like to sit down while the chili is being made, and then maybe have it delivered to me in a semi-truck or whatever, right? Like that's a lot of chili, right? Like a couple wagons worth. Oh. I like how the screen blacks out and gives you like a minute to just breathe. You're like, just mindfulness. So I would like to be able to sit down while the chili is being prepared. In default, regular JavaScript though, here's what happens is JavaScript will start running the code from the top down, right? I'll start running the code, console log, what can I get you? Cool. Then it goes to order and prepare the chili. Cool. Order and prepare the chili. This means it's going to run this function now. And JavaScript will genuinely just not get to this until the previous line is finished, right? In default, like regular JavaScript. I will just not get into this until this line has completed running. So if I was to go see maybe what the order and prepare chili function looks like, so here is const order and prepare. And then this might take some food and some quantity. This is a function order and prepare with some food and quantity. And I might find that this is a very expensive function. Right? When I say expensive, I might mean that this has a lot of stuff in it, right? And it takes a long time to run. Right? For example, this is going to have to loop over for let I equals 0 while I is less than quantity, and then I plus plus. It's going to have to make some chili. We'll go console.log, and then pretty sure there's a. All right, well, we're gonna say chili dogs. I don't know, soup. There you go. Making some. We'll assume that this ramen is chili. Right. So it's gonna be console logging chili, and then at the end of it, it'll maybe console.log ding. Right. At the end. So this function does not finish until it's gone through every order of chili that it needs to make. Now, we're going to play a little experiment here. We're going to go into Node, and I'm actually going to run this, and we're just going to see what happens. So I'll make a new file. We're going to call this one bigmeal.js. That's our big meal. So if I was to look at this, I have an order and prepare function that doesn't run yet. First, I console log. Then I order and prepare. Then I console log. And then I sit down. Actually, I need a sit down function. So const sit down. This one's just going to console.log like a chair. Is there no chair emoji? What? Couch. All right. This is a nice, comfortable restaurant. Sit down. So I'm going to run this code now. We're going to go node, big meal, and I press enter, and it's just going to run. It's going to run, and it's running. And it runs for a while. 9 million times. There's a lot of chili. Computers are great. Computers are very fast and all that, but even they'll freak out if you tell it like 9 million chili. It's a lot. I could scroll up and down. I can't even scroll down. It won't let me drag it. It's like I refuse. It is definitely still going. Needless to say, this was a terrible idea, right? And I could scroll and scroll and scroll and scroll, and it actually goes well beyond where I'm able to scroll to. Okay. Now, fair. We didn't end up seeing the sit down print anywhere. If I was to decrease this number just a little bit, let's do something a little less intimidating. 10,000. 10,000 chili, I could do that. Give me a day or two. We'll run it. The important thing to see is that it does go ding, then cool, will be ready soon, and then sit down. Right? So the thing that I'm trying to say here is that sometimes there are functions that take a while to run. Right? I have made a, what do you call it? It's a very contrived example. Right? The making 10 million orders of chili. I don't know how often you're going to make like chili ordering simulations at work, but you will be doing other stuff that maybe takes some time to run. For example, you might be processing a gigantic amount of data. Or you might be running some code that goes and needs to make a request somewhere. Right? You might be running some code that needs to wait for somebody else to reply. And now you might not want all of your program to halt and stop and wait for that. You might want some of your program to continue. Right? For example, my sit down should happen while the chili is being ordered. And so that's the concept that we're going to try and solve today, right? Is that we're going to come up with a pattern, or rather use a pattern that lets us encode that kind of behavior. Now, the particularly important thing here is that after I have ordered and prepared the chili, I want to present the chili to the customer. Right? I want to have the chili be presented. So not only does this function need to run, but I need to use the output of that function. I need to use the output of that function. So if I was to write this in the regular way, I'm going to go const, here's the chili. We'll order and prepare some chili. We'll put it in here. And then I might go down here and say, oh, OK, well, here's your chili. And then here's the chili. My chili might be a big array of stuff. Or in my case, what I'm going to do is I'm going to say, when console logs ding, it returns basically a truck of chili. Right? Just a whole lot. So when I run this now, at the end, it says, OK, well, here's your chili. Now, I use this example here, sort of, again, as motivation for a particular idea. We're not actually going to stick with this example too long, because it gets pretty contrived pretty quickly. What I'm going to do is I'm going to move away from this a little bit, and towards the end of the lecture, we're going to come back to a similar idea, right, with ordering food. What we're going to do is then we're going to beast it up a little bit and have multiple people ordering many amounts of food. Right? But this on its own is an idea of something that takes a while, right? Like, again, we say an expensive computation, right? It ideally doesn't have to happen in sync with my life, right? I, as a customer, I don't need to stop and just wait for the food to arrive before I can move again. I can go do other things. Right? What we're seeing here is a bit of a distinction between two ideas. There's sync, and then there's async. Synchronous control flow is fairly simple in the sense that there isn't very much to think about. Synchronous control flow is going to go from top to bottom. And after every line, we will go on to the next line. Right? Asynchronous control flow is the opposite. There's a lot to think about, because all of a sudden, your code doesn't run in the order that you expect it to. Some lines of code might finish before other lines of code against what you thought might happen. I'm going to try and show you what I think tends to be one of the clearest examples of an asynchronous situation. async1.js. So we'll think of something that maybe takes a little while to happen. I don't know. What in your life, I'm just trying to think of an example here. In your life, what things take a while to happen? Elevator. That's a great one, yeah. Elevator. So we're going to do a little elevator example. I wonder if there's an elevator emoji. Nope. We will do a door. There you go. The little elevator door. So there is, in this example here, maybe the idea of an elevator. You press the button, then the elevator comes and you get on. I cannot get on the elevator until the elevator has arrived at my floor. Right? I can't just press the button and be like, don't you know who I am? And just walk into it. Like, I have to follow some rules. So I might start off by press elevator button. Right? I start off by pressing the elevator button, and then I can't immediately like get on elevator, right? We'll say request elevator, and then get on elevator. So if I have my const, request elevator function, this is going to take a little bit of time. Right? One way for me to force time passing in JavaScript is to make a for loop. Right? I could make a big for loop like we did a minute ago, and just ballpark. Just make a really big for loop and just kind of, oh, this might take this amount of time. Not a good way to do it because every computer is going to run slightly differently. If I'm on a really old computer, it might take a long time to count all the way up to 999999. But maybe if I'm on a supercomputer, it'll just happen like that. So as programmers, it's not like we want to, okay, figure out what's the computer's processing power, how am I going to like pull out my calculator or whatever. Instead, what I'm going to do is maybe use a function that lets me say, wait this amount of time. Okay. So there is a set timeout function. There's a set timeout function. And I can say, hey, set timeout, and I can tell it to do a particular thing after a certain number of milliseconds. So let's say that the number of milliseconds here is going to be 1,500 milliseconds, so 1.5 seconds. And say that the thing that I want this to do, I want it to console.log a, just that. I want it to console.log these lines. And now, it is not possible for me to say this. Oops. Set timeout 1500 and then console log a. What I will find when I do this, so this is async 1, is I get an error. Specifically, the way I'm calling the thing at line, where are you at? I think at line 11. It says error invalid callback. I could take some time to maybe go read up what this error means. I'm going to make you try to think about it a little bit. If I was to set a timeout and say that here is a particular action that I want you to run after a certain amount of time, I know the answer was just posted up on the screen, but what is the construct that I might want to use for that? And if I want to say here's an action that you can use later. Maybe like, hey, this is something that you can maybe call back later. Some kind of function being passed in as a parameter as something that you could somebody just say the word callback? Oh, thank God. All right. OK, callback. So yeah, I can pass in a callback. I could say, hey, here is maybe the callback that I want you to run, right? Console.log, right? A. And what I'm able to do is say set a timeout for 1.5 seconds, and then run this callback. Right? So that's the basic way that set timeout is going to work is I need to have something being passed in as a callback, and then I say how long it's going to take. And it waits 1.5 seconds, and then it goes, A. And the thing that's really funky about this, right, and this is where async really starts kicking in, is if I go console.log, what up? And maybe just some other stuff like, dude, what's that? Oh, the screen's black again. You know what? Let's try this other one. There we go. So maybe something else like doot, just all sorts of stuff. Anybody got an ad lib? Is anyone here like a rapper or something? Anybody want to shill their new mixtape? What's that? Yeah, what's your SoundCloud? Oh, man. What's your name? All right, Anthony's I'm going to do this with 2 caps. Anthony's fire mixtape, right? Out now. Yeah. So I have all these things being console logged, and what's interesting about this is when I run this, whoa, why did my code get so aesthetic? Look at that. I have no idea that. Travis, you see this? Whoa. This is like the Simpsons wave. So what I get is, what up, doot, Anthony's fire mixtape out now, and then A, right? So the code that I wrote after the set timeout actually runs before the code that I've put into the set timeout, right? And that's very important to get. Okay? This stuff here does not wait. Doesn't wait. So if I was to use the same idea in my elevator example, so we'll do elevator. What I can do is I can say, hey, here's a function that requests an elevator where what request elevator does is it goes console.log boop. That's the sound that you make when you request an elevator. Then it's going to set a set timeout. And maybe the elevator takes like 2 seconds. All right, it takes 2 seconds to arrive. And I can say, OK, well console.log elevator is here. Is anyone confused by what I've done here? It's an anonymous function, right? So I just wrote it here so that I didn't need to make another function. Remember when I taught callbacks last week, I said one of the reasons that we might use anonymous functions is because that way we don't have to come up with names for them, right? I have no idea what I would call this function right now. I'd have to think about it and maybe go like, OK, const elevator is here. It kind of feels like a waste of time. So I can just use it in line. Right? So set timeout, and then after 2 seconds, it says elevator is here. When I run this, after 2 seconds, whoops. After 2 seconds, it says elevator is here. So boop, and then the elevator. And what I want to do is board the elevator, right? Get on the elevator after the elevator arrives. So const request get on elevator. It's going to be a function that says console.log get on elevator. So as we know, this structure here won't work right now. Right? It shouldn't work because get on elevator is being called directly after request elevator, but due to the async nature, I get on the elevator before the elevator arrives. Right? So what I want us to think about here now is how do I modify this code to ensure that get on elevator only happens after the elevator has arrived? Mm-hmm.
You can have that function called after, inside the require elevator, right? After callback.
Cool. So what's that going to look like?
So just cut that break and then paste it inside the function.
Paste it inside of, and where in here?
After that 2000.
After here. Right there? Cool. So what we're looking at here now is there's one call to request elevator. Request elevator says, let's go up here. Console log boop. We'll set a timeout. After 2 seconds, it's going to print console log elevator is here. And then I also have a call to get on elevator. And I want you to see what happens. So did that work? Not yet. Didn't work yet. And the reason for that is, again, I haven't gotten around the issue of the fact that this set timeout, this function here runs after 2 seconds, but this function here runs immediately. How do I make get on elevator happen after this console log? Can we set a timeout? Sure, what's that going to look like? And what's our timeout? You're gonna make it 4 seconds?
Yeah.
All right. So, clever is a good solution. Sure. I run this now. Boop. Elevator's here. And then after 2 seconds, apparently, I get on the elevator. Yes, sure. Not that it doesn't work, but what we've kind of done here is like, well, the door is locked. Good thing I have this axe, right? Like that's you've kind of broken the issue here. So sure, I'll set timeouts for absolutely everything to make sure that they happen one by one. Clever. Not the solution that we're going to go for, though. Right? So yeah, very close. So how do I make anything happen immediately after this console log? What's that? Right. So, whoop, and then I could take this and put this up here. Right? Not a bad solution until we think about kind of the ramifications of this. So I've said set timeout, then console log after 2 seconds, and immediately after that console log, then in here I'm in its own async world, I'm in its own sync world. This situation is asynchronous, but the code that I write in here is synchronous. So I console log and then I get on elevator. And if I run this right now, boop, elevator is here, and then I get on elevator. Right? Again, I've sort of forced the situation because what if sometimes I want to request the elevator and get on, and other times I want to request the elevator and then go, you know how sometimes you call an elevator and it pops up and there's someone in there that maybe that you haven't seen in a long time, and you go like, oh no, like I didn't want to catch up right now, and you just kind of maybe look at your phone a little too long and go, oh no, as the elevator is closing. Is that just me? I feel like that's just me. What we're gonna do is awkwardly miss the elevator. Right? So sometimes I might get on the elevator, but other times I might want to awkwardly miss the elevator, like awkwardly miss the elevator. And I'll pick an awkward face. This one. Does this face speak to people as much as it does to me? I feel like most of my life is just okay. So how do I do that? Right now, sometimes I want to request the elevator and get on, and other times I want to request the elevator and miss. And there's a very slight modification that we can make to the code as it is right now. So over here, I'm going to say, when the elevator arrives, right, get on it. And this one's when the elevator arrives, miss it. So I want to encode an action in here. Like I want to say, this is what you should do later. What might we use for something like that? Might use a callback, right? I don't want to get on the elevator right now, but I'm saying, hey, later, when you need to get on the elevator, here is all you need to do for that. So in one way or another, I want to pass in here the thing that lets somebody get on an elevator that they can use later. What's that going to look like for me here? What am I going to want to write? I think we're thinking a little too, that's good. Like, overcomplicating it a little bit. I'm going to say that this here specifically, we're not going to check the person that's on there. I'm just going to say that for this one here, this one's going to be get on the elevator. And for this one here, I want to say miss the elevator. Okay. How do I tell this function call for request elevator that this one here needs to get on the elevator? All right, like what options might I have for this? Yep. I might pass in get on elevator. I might say, hey, here's request elevator, right? Call it. And then here's get on elevator that you can use later. Right? That's the concept of a callback function, is I'm saying, hey, this function here, you can use this later when you need it. If this one here is for missing the elevator, I might say request elevator and then awkwardly miss the elevator. Right? Where these two functions are not being called yet, get on elevator and awkwardly miss the elevator, they're not being called yet. They're being passed as callbacks to requesting the elevator. Right? And the reason I'm doing this is because what we'd done earlier, right? What we'd done earlier was we'd put get on elevator here right after the set timeout. And the thing is, I don't always want to get on the elevator, right? I want to do something like dynamic. I want to do something dynamic with the elevator once it's arrived. Sometimes I want to get on it, and sometimes I want to awkwardly miss it. Either way, I want to do maybe some elevator action. Where do I get this elevator action from? All the way back there. Where do I get the elevator action from? Yeah. Right? So once this has been passed in, get on elevator has been passed into request elevator, right? How do I access that once I'm inside of request elevator? I need to put it up in the parameters. I need to say that request elevator is going to receive some maybe elevator action, right? It's going to receive something to do. And that elevator action might sometimes be to get on elevator. Other times it might be to awkwardly miss the elevator. And we're going to see now that when I'm going to toggle one of them on and one of them off. So the first time we're just going to get on elevator. When I run this right now, what happens is I boop, then the elevator is here, and then I get on the elevator. And other times, if I do the awkwardly miss the elevator, so I've commented this one out, and I'm bringing this one back in, I boop, then the elevator is here, and I awkwardly miss the elevator. So the particular thing that we solved here is there is a pretty generic action, calling an elevator. Right? And there are many different specific things that I could do when the elevator has arrived. So I can write code such that request the elevator, since it's an asynchronous action, right? It will take some time, but it'll receive the particular thing that it's supposed to do afterwards through a callback. Right? This is the main problem that callbacks solve for us, right? When we're working in JavaScript, this is one of the common places where you're going to use callbacks, is when you know something's going to take some time and you want to give it something to do later. And does this concept make sense? Yep.
So can you scroll to the set timeout there?
Yep.
Like, that function there, like we have two parameters in the set timeout, right?
Mm-hmm.
One is the function, and one is the time set.
Mm-hmm.
So for the second parameter there, can we pass one event or function in?
Like into here?
No, in the 2000 there.
Oh, in here?
No, the 2000.
Oh, the 2000.
Right.
So this is going to be 2000 unless you make this a variable. Like if I say this is time.
I mean, like, can we? Does it have to be a time? Can it be a like an event or function? You know?
Oh, like do this when this happens? Ooh, that's a great question. So in set timeout, no, right? Set timeout is going to be a situation where I specifically say, wait for this amount of time and then run this code. But there are going to be functions, and in fact, you know what? We could play with them in the second half of the lecture that say, do this when this thing happens. Right? For example, when you press a key, do a particular thing. Right? Like we could do stuff like that. Totally. That's a great situation for callbacks. Right? Is to register a function, right, for a particular event. Right? That's a great question. In fact, since it's 10:55, we will take a break in a minute, and then towards the end, I think, of the lecture, we'll play around with something like that. This is the basic point of async and callbacks, though. Right? Is stuff can take some time. In here, I actually forced it to take 2 seconds, and then we can tell it to run something afterwards. Right? Callbacks can get more complicated, right? But in any one of the cases that you find in the future of callbacks, like you can reduce it down to this situation. Right? Are there any questions about this specific example at the moment? Yep. Exactly. Exactly. Absolutely. That's exactly what it is, right? So callbacks specifically, the pattern is great for when something is done, here's what you do next, right? That's why I find that like things like this, like elevator or the one that I started off with the ordering the food, those examples tend to make like some sense, I think, because you're ordering stuff and you can't do things with it until it comes back, right? So in the next half, we'll come back to sort of an idea like what we started with the ordering food. It'll be a little bit more complex. Right? Are we good to take a, let's see, we could take a 14-minute break. Okay? Treat you to an extra minute. Yeah. we'll do a 14-minute break. I'll be up here if you have any questions, or I'll be playing video games. Hey. Yeah.
Like just for this one,
Mm-hmm.
so just want to clarify with you, like we need this like parameter for this function. It's because that we want this parameter like to do something like here, because we want like here we need like callback function. So that's why we need it.
Exactly.
And if without it, like we can't really.
Then it doesn't know what the elevator action is. So when I do this, then it's going to say in 2 seconds. It'll say elevator action is not defined. So I need to define it, right? And then specifically, I need to pass something in. Because if I don't pass something in, then it's going to say elevator action is not a function because I didn't give it a function.
So what if like I give it like a callback function like this one, and I call it, and it won't be passed like it will be passed like here, right? But I can't really use it here?
If you don't use it, nothing happens. Right? If you don't use it, then it doesn't really care. But if I want to use it, then I need to pass it.
I want to use that function, so I need to pass it into the parameter and let the parameter call that function.
Exactly. Yeah.
Another question is that for the callback function, so the callback function that, like for example, like this one and this one, they don't need to be like declared before that one.
Oh, you mean declared up here?
Like,
no.
Before.
No, they've technically been declared before they get used, because this gets declared, but it doesn't run. Right? And these get declared and they don't run. If I tried to do request elevator before I declare that, then it breaks. Right? Because then it's going to say,
okay.
I don't know what awkwardly missed the elevator is. So I need
even though I declared it like later, it doesn't work.
Exactly.
So I call it. So I declare it before I really call it. Okay.
Yeah.
Oh, that's cool.
Nice. Sweet. Did you have a question?
This might be a stupid question, but how do you pull out this terminal thing?
Oh, it's going to be control and then the tilde. Oh, so you're on. Oh, you are on VS Code. Nice. Yeah.
So control
Cool.
and this thing.
Yeah. There you go. And then it takes a second. But you're not in Vagrant, so you need to do the whole. Oh, sorry about that. You need to do the whole like SSH into Vagrant again.
But this is the exact same terminal.
Oh yeah, it's the same one. Yeah.
I have
No problem.
another question. Like when you were talking about object,
Mhm.
back to the object.
So the object, I think I put up here. Yep.
Okay, like I'm a little bit confused with.
So this is the async control flow, but the objects are a bit higher up.
Oh, like for this one, what does this mean?
Mm-hmm. So see, this is my things to remember,
Yes.
and they have a number, a name, and a food.
Yeah.
Right? So I can either say things to remember number,
Number. Yeah.
or if I have a variable, then I can use that variable in here.
Oh, they collect like a food.
Mm-hmm. So then I can change this.
Okay. Yes.
I can change this to name, or I can change this to number, right? Or food, and that's useful for when I want this to be dynamic.
So dynamic. So like it call pass like the variable key and okay. So now the key actually the string of food and it's gonna like find the key food. Okay, I got this one.
Yeah, that's perfect. That's exactly it. Yeah.
Oh, okay. Oh, good.
Nice.
Understand that. Thank you.
Awesome, no problem. Oh my god. unconventional. Yeah, I mean, we might. I think we're gonna do some like funky stuff with Scratch, just to get ourselves thinking with callbacks. Scratch is an amazingly powerful tool. Again, I've been thinking for later in the boot camp when y'all have advanced lectures, I might do like a full hour on Scratch, just take you through like advanced Scratch. If anyone wants to do their final project in Scratch, by all means, come talk to me. We can make it work. We probably couldn't, but I would like to have that conversation. So Scratch has all these little fellas. You can have little cats. You can choose a sprite. So every one of these characters is called a sprite, and I can choose to have more of them. I'm gonna make Scratch at 100 actually is pretty good. I could choose a background. Right? So we're gonna pick a surprise background, and we'll see what that is. Surprise! Whoa! Surprise! Here's another one. Surprise! We'll do something. This is nice. Nice surprise. So here's Scratch, and I can make multiple characters on here. Surprise! Here is another character. I'm just gonna make this character a bit smaller, so we'll do 50. Right. So I have all these different characters. I have 2 of them. I might make more. Now, the reason I'm showing you Scratch right now is to kind of touch on the idea that you were saying is like, can you set something to happen at a later point? Scratch actually uses callbacks in a certain way. I can say things like, for example, when the flag is clicked. Right? So when the flag is clicked, then stuff is going to happen. Right? So something I showed you last time was when the flag is clicked, I might glide 1 second. Right? So it takes 1 second for me to glide to a random position. And if I was to just click on this block on its own, I would see what that means. For 1 second, glide to a random position. Right? Now, this block existing doesn't mean it's running right now. It runs either when I click on it to invoke it, or it runs when the green flag is clicked. So I've registered an event. Right? When the green flag is clicked, Scratch is going to go to a random position. Now, I can make this stuff more complicated. I can say when the green flag is clicked, don't just go to a random position once, but maybe forever. So this is a continuous loop. Keep going to a random position. And there is like surprisingly asynchronous stuff here. For example, one of the things that I can do is I can say something like, wait 1 second. Right? So forever, then glide 1 second, and then afterwards wait 1 second, and then continue. And so it goes, stops for a second, then it goes, stops for a second, then it goes and stops for a second. Now, Scratch is pretty limited, but one of the things that I can do is I can remake this code over for the witch here to be able to do the same thing. Interestingly, there's this idea here. When the flag is clicked, forever glide 1 second, then create a clone of yourself, and then after a second, glide again. And as I start this, you see that Scratch is leaving clones everywhere. Right? And what I would like to do maybe is be able to say, hey, when you start as a clone, do that stuff. So not only does Scratch start off when the flag is clicked, but after a little while, they've like so many of them, right? The cat itself is called Scratch, which is why I call cat Scratch. Again, the reason I'm showing you this is, for one, because it's goofy, but for two, because it's, again, important to see that this code here is not, it's not running right now. It runs later. Right? it runs later. I can do even funkier stuff in here. I'm not going to spend too much time in this anymore. You can have Scratch broadcast messages. So messages are like events. And then you can have somebody that listens for that message or that event. Right? So similar pattern to what we might do in JavaScript as we go forward. So we're going to be doing similar stuff as we're working here in JavaScript. When we finished earlier, what we had was the elevator example. There are, let's see, there's one or two more things that I want to do. Specifically, I want us to go through a weird example called sleepy. So here's some code. What does this code do? What's that? The turns might slow down as we go through the array. Okay, so what do we expect to see? There's a console log here. What do we expect to see console logged? The numbers. And can you give me like a list, like what numbers get printed out? So if we were to break this down, we do have an array of numbers. And it goes, like you were saying, 6, 2, 3, 5, 1, 6, and 2. Then I have a function called sleepy. And sleepy is being called on the numbers. Right? So the numbers are being passed into sleepy. And then what am I saying here? So, well, with my set timeout here, what I do have is, let me break this up into multiple lines so we can see. My set timeout takes two parameters. It's taking a callback. And what does this callback say? Yeah, so it prints out the number. Okay, so this one says print out the number. And what does this one say? Use the same number as the timeout. So as we're looping through each one of the numbers. So first 6, then 2, then 3, then 5, then 1, then 6, then 2. And this is saying set a timeout for that particular amount of time. So the first time it might be 6 seconds. The second time it might be 2 seconds, then 3 seconds. Okay. Where the amount of time that we're waiting is associated with the number that we're at. And after that timeout has finished, I will console.log that number. And you see what happens now. So my numbers are 6, 2, 3, 5, 1, 6, and 2. So I'm going to run node sleepy.js. OK, that was really fast. Oh, yeah, there you go. So what happened? How did the numbers get printed out? Sort of. Right. They went 1, 2, 3, 6, and 5. This other time that I ran it, it went 1, 2, 3, 5, and 6. If I was to run this over and over again, I would usually get a similar order. 1, 2, 3, 5, 6. If I was to make these numbers a bit bigger, it might be a little bit more obvious. So that's a 5, 1, and then the 2. Right. And if I run this now, I got 1, then I got the 2s, then I got the 3, then the 5, and then both the 6s. So what this did is, for each one of the numbers, it set a timeout. And then it console logged the number after its particular timeout had done. what I've done is I have somewhat of a sorting function, right? This function takes a bunch of numbers that are out of order and prints them out in ascending order, because it's kind of like I'm setting a bunch of alarm clocks, right? Just a bunch of alarms. And then these alarms all fire at particular times. So this loop happens almost instantaneously. It does happen in order, but it happens almost instantaneously. So I have a bunch of timers going off for 6 seconds. This one's 2, 3, 5, 1, 6, and 2. So it makes sense that this one's going to be the first to fire off. Then these two are going to be the second to fire off, probably around the same time. Are they going to fire at exactly the same time? No, but around the same time. Right? Then this one is going to fire off, then the 5, and then the 2 6s. This is, again, just a weird example of using callbacks and async stuff. But I wanted to throw a little bit of a curveball at you. Is this really code that you would write to sort an array? No, because what if I did something like this? 12,000 was one of my numbers. What's going to happen when I run this code? It's going to take a long time. It's going to be 12 seconds before the 12 goes off, right? Which is kind of nuts. I don't want to wait that long. But it's a neat example to kind of think about, where I have many of these timers, and they're all firing off. I don't know if any of you are Pink Floyd fans, but I think of sort of this. You do. Like, that's what I see or hear in my head every time I run that function. Right? So does that idea make sense? Right? Not exactly why we would want to do something like this, but this is more of just a cool puzzle. And I really recommend taking a look over this code, right, when I send it out, and challenging yourself a little bit. Maybe try and figure out how you would make this run backwards. Can you print the biggest one first, and then the next biggest one, and then the next biggest one down to the smallest? Right? I think that's a fun challenge to do. How do we print the numbers in descending order? So I want to show you a couple more demos. These are going to be, I don't want to call them advanced, but like sort of stretch. The basic concept of callbacks we've touched on with this elevator example. Right? We've touched on it with async 1 and with elevator. If you're comfortable with that idea, then you're good. Right? Something that you might even see is like, I can have multiple elevators going on at the same time. I can have multiple elevators going on at the same time, and my program handles that stuff properly. Right? Now, what I want to build over the course of the second half is I want to kind of elevate this idea. Oh, pun unintended. I want to add some stuff to this, and what I want to build is this. We can go into our README and we'll highlight this. So we're going to build the restaurant sim 3000. Right? This restaurant simulator is going to have everything. It's going to have ordering food. Ordering food. Right? You want to order food? You can order food. It's going to have greetings. Right? People will greet you when you order stuff. It's going to have a menu. A menu to pick from, so you can pick the stuff that you want to order. What else is going to have? It's going to have serving. Right, so after food has been ordered and after it's been prepared, that food will be served to you. We're going to talk about this restaurant at a high level, right, and then we'll start building it. Right. At a high level, then we'll talk about the features of it, and then we'll build it. So you'll watch me kind of build it slowly. Right. I'm going to do my best to explain all the code that I'm writing. But at some points, I might just say, hey, this stuff here is a little bit extra, but I need to do it to make it work. and then you have the opportunity to kind of talk to me afterwards to get more of an explanation of what that code does, right? Or just dig into it, read the docs. So in my restaurant sim 3000, I'll explain what this is. It's a command line program. It's a program in my command line that starts off with a greeting and a menu with 3 options. Right? It's got a menu with 3 options, and my 3 options at this restaurant will be, I don't know, what are y'all hungry for? Chili. What was that over there? Bacon. Just a big old plate of bacon. Anything else? Spice. Bacon, chili, spicy chili. All right. Anything to drink? So what we'll have maybe mains, and then we'll have some drinks too. I'm gonna go for a kale smoothie. Yeah, very Vancouver. Scott, you hungry, man? Yeah. No. What do you want to eat or drink? McDonald's. All right, just a big old Big Mac. Yeah, cool. Kale smoothie. Anything to drink? We can go for good old ice cold water. And root beer. Perfect. Right, kale smoothie, water, and root beer. We've got all kinds of options here. Some of these take longer than others. For example, the chili. This is gonna be a quick kind of. They've made it overnight, so you just kind of ladle it in. So the chili is going to take 2 seconds. Okay. The bacon, they're going to go through the full process for this. So it's going to take a while. I'm going to say 10 minutes. No, 10 seconds for this. It's going to take a while. The spicy chili, they need to ladle the chili out and then add some spice to it. So this is going to be 3. And then the Big Mac, this is going to take maybe 4. Okay. Kale smoothie is also going to take a long time. It's going to be 7 seconds. Water, best drink, 1 second. Root beer, 2 seconds. And so I have all these different things that have some process to them. Okay. Have some process to them, and they will basically go down, not a conveyor belt, right? Because I don't need to finish one and then do the other. They'll sort of all be happening whenever they get called for. After you have selected one option, that menu item will be created. Right? And importantly, you can immediately order again. As soon as I've made an option, I can immediately order something else. Make sense? Cool. So I'm going to take this idea here. I'm going to make a restaurant.js. I like to keep my description up here just so that I don't forget what I was going to do. Yo, Josh, Gary, sorry. Like carries sound really well. So what I'm going to do is I can start off by maybe saying, okay, when you start off, print greeting, and print the menu. These 2 functions don't exist yet. So if I was to go node restaurant, they don't run, gives me an error, which is good. And you go by like an error-driven development approach. So I want to print greeting, print menu. Maybe I want to do something like get selection or something. And then order or like create item, something like that. I know that this is not the way that I'm going to be writing this code because there's going to be asynchronous stuff happening all over the place. But I'm just writing this out as steps for myself. Print greeting is going to be a function that says, welcome to, and our restaurant is called welcome to Lighthouse. Yeah, Lighthouse. Welcome to Lighthouse. What can I get you? And then I also want to print the menu. going to print the menu, and specifically, I want to make this thing pretty dynamic. I want to write this program pretty nicely, and I don't just want to hard code my menu. I'm going to make the menu printing take in maybe menu items. Take in menu items, and what I want to do is I want to loop through maybe like const item of menu items and do something with that. Right? If I was to look at what my menu items are going to be, I'm going to say, here's my menu. My menu is going to have all of these. I see some crazy stuff. Bow, bow, bow. No. Bow, 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 bow. Whoops. Oh, I went too far. OK, we'll do that again. Bow, 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 bow. Boop, boop. Boop. And then we'll do this one. Bow, 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 bow. Boop. That's how you really use VS Code. So. If you don't know, like you can press Command D. When you've highlighted something, you can press Command D, and it'll highlight everything that matches that. And then you can blah, 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 do all that stuff all at once. Pretty cool. Oh, absolutely, yeah. So here's my menu. It is an array of arrays. So as I go through this, I'm going to console.log for each item. Item 0. And then item 1 for the time. And when I run this at the moment, I'm going to go node restaurant, and it should cannot read property 3 of undefined. What did I do? Yeah. Oh, there you go. Pow. Oh, that's what I forgot, was to put commas on all of these. My sound effects got the best of me. There we go. And now menu items is not iterable because I never passed the menu into the print menu. Okay, so here are all the items: chili, bacon, spicy chili, Big Mac, kale smoothie, water, and root beer. Right? Each of these has an index. So we're going to say the index of the thing. So I'll change this to item index. Item is going to be the menu items with the particular item index. And it's going to say press the particular thing. So item index. Press item index for that particular thing. So I'm going to get press 0 for chili, press 1 for bacon, press 2, all that. And now what I want to do is I want to listen for the thing that is being pressed. Right? I want to listen for that. Heads up, I'm going to make a couple of mistakes. I'm going to go look at some code that I already have. Right? I'm going to throw that in there. Get ready for a little bit of frustration as you watch me make syntax errors and just get lost. At the end of the day, this is going to work. So I might go online. I might say, OK, with Node, and here's a hot tip. When you Google stuff, you can straight up Google things in the form of a phrase. Hey, Google. Hey, Google, how do I listen? How do I listen to my voicemail? How do I get rid of fruit flies? How do I? I like the how do I. If you do how do I TAL, it's like how do I talk to a CR agent? How do I talk to a live person at Groupon? How do I talk to my crush? Oh. So how do I listen for key press in Node, Node.js? And the thing is, when you write stuff in the form of a question, like most of the time, somebody's already asked a question like that on Stack Overflow or something like that. Here we go. Capture keyboard press. capturing user input. This thing here is for the web, so it's not necessarily going to work for us. What we care about is Node.js applications. So I might look at some of these. Example, capturing user input in a Node.js application. I could bring in a thing called read line. And the only thing that I really want you to pay attention here is I don't even know how this code works. I haven't used the read line package before, but I do immediately see that this thing is happening. And what is that? It's a callback, right? So callback's probably going to be useful in solving this. Right? That's going to be the pattern that we use. Because the key is not going to be immediately pressed. It might be pressed later. Right? Generally, over the course of boot camp, if something doesn't happen now, but it happens later, right? Place to use a callback. The way I like to do it is, actually, I'll show you in a second. I'm going to use a particular thing here. Where'd you go? Called standard in. Have you played with standard in yet? No. You were playing with standard in a little bit today. You've been playing with standard in at like different points over the course of the week. I'm going to, at the bottom of this thing, just as we kind of sandbox it out, I'm going to bring in a thing called standard in, and it lives inside of this process object. Have you seen the process object before? No? Well, let's take a look at it. And you go console.log process. Did I declare process anywhere in here? No. What do we call it when there's something built in that I didn't make, but that I have access to? Right, one of these variables. What are those variables called? They're like global variables, right? Or environment variables. They're like built in, right? I have this by virtue of being inside of Node. I have access to process. If I was to look into process, it is what kind of thing? Let me move way up to, wow, process is huge. Process is what kind of thing? It's an object, so I can access stuff inside of it. Specifically, I'm going to access process.stdin, standard in. Standard in is going to be a object that's going to give us access to a bunch of functionality for dealing with input. Okay? For dealing with things like key presses, right? That's what we're going to be working with. Now, I already have some code to work with user input. I'm going to play with this in a little bit of like a sandbox, and then I'll move it into my restaurant stuff, because I want you to see what standard in does. I'm going to do this. I'm going to make a new file. It can be called standard in. I'm going to paste in as little code as I can. OK, this is all the code that I have in this file right now. I have standard in. Right? I could even, instead of writing stdin like this, I could go process.standardin every time. But I'm writing it like this so that I don't have to write the word process every time. This right now is saying set raw mode true, set encoding to UTF-8. What does that mean? I don't know. I don't care. That's not what this is about. We're going to hide this. It's going to go just, look at that. So nice. It's as if that code wasn't, you know what? You want to see, here, we'll do this. Process.standardin. We don't even see the declaration of what standard in is. Right? Trust me for now, these two lines of code, just have them in there and don't care. Right? They're just in. They're like preparing. It's like revving the engine for the you know, whatever. It's just in there. We're going to run node, and then my file is called stdin.js. What's it doing right now? Maybe. But specifically, unlike the other programs that I ran, this is, at the moment, not ending. every time I press a key, like I'm Beethovening this, like it reads the key and then it prints it out. Okay. You know what's funny is if I wanted to get out of this program, how do you usually quit a Node program if it's running? Have you had to do that before? Control C. So Control C is a key press. What happens when somebody presses a key? Well, anytime there's new data through the input, it will console log that. So here is me pressing Control C. Right? Like, no. Right? Help. What's that? I don't know. Yo, Travis, do you know how to exit ed? Yeah, I have no idea. Do you know what the best way to exit ed is? Is the little trash. Kill the terminal. So that's what I'm going to do for this one right now is I can trash and I can leave. It's pretty funny. I can do that with, if I put in an extra line in here in my whenever there is data. So this is whenever there is data, run this function. I had been console logging whatever key had been pressed. I can also check to see if the key is \U0003. This is just the Unicode character that represents the Control C. Right? So in this case here, then I'm going to exit the process. Right? This way I don't have to like trash my terminal every time. Control C is going to quit for me. Right? So that's just some standard stuff that I'm going to need in here to be able to use this stuff properly. But if I'm able to toss this kind of key in, right? If key is this, then I'm also able to say something like, OK, well, if key equals, and I might say, OK, well, if the key is 1, right, then we'll console.log A. OK, Y, A. I've put in some extra special functionality for when the key is 1. So I write a bunch of stuff. And then when I press 1, it didn't do it. Why didn't it do it?
Is it because 1 right now is a number? And when you press 1, it is a string?
Yeah. So probably because the key coming in is going to be a string, and I'm checking to see if it's a number. So I might do this. Right? So we'll try this. And then when I go and press 1, A, right? And that works. So I have successfully figured out how I can attach specific listeners to specific keys. Right? And I can have special things happen when different keys are pressed. So here's what I'm going to do. I'm going to take this situation. I'm going to go over to my restaurant. And I'm going to do something like this. I'm going to say, ignore all this stuff. That's the standard in stuff. But this is going to say, anytime there is data, whenever a key is pressed, if it's Control C, then I want to leave. Right? I want to get out of here. But if it is one of the keys that's in my menu, then I want to order that menu item. So I could do this. I could say if the key, and then to make things simple for myself, I'm going to turn the key into a number. I'm going to turn the key into a number because I can use numbers to access stuff in arrays. Right? I'm going to use the key, so whether it's 0, 1, 2, 3, whatever, I'm going to use that as the index in my menu. I'm going to say, OK, if there is something in my menu that matches that key, I'll write this out like this. Give me my menu. So my menu up here. Menu. And then I'm going to use the key to access the thing in the menu. And what we're just going to see is there anything for that? You notice I can get rid of these if statements at the moment, not do anything with them. And get rid of this. And the way that I'm going to do this is I'm going to say we're going to print the greeting. So this is really all the code that's kind of running, except for the functions that we saw earlier. We're going to print the greeting, then we're going to print the menu, and then whenever somebody presses a button, I'm going to try and print out whatever is in the menu that matches that key. So this is our restaurant. So I got my greeting. Welcome to Lighthouse. What can I get you? I can press 0, 1, 2, 3, all the way down to 6. If I press 5, then I get water. If I press 2, then I get spicy chili. If I press 0, then I get chili. What do you think happens if I press J? Undefined. Right? And we can follow why it's undefined. If I press J, J goes in to here. Then J is going to be turned into a number. Can you turn a letter like J into a number? I don't know. Right? We could try to see in Node what happens when somebody goes number of J. Not a number. And then when I have an array, if I try to, so let's say let R is 1, 2, 3, or whatever, just some array. If I try to index that array with not a number, what's the result out of this? Yeah, I do. Good catch. If I try to index this array with not a number, what's the result? Undefined. Right? So arrays they tend to be pretty forgiving. They won't throw an error. They'll just say undefined. So that's what's happening with my situation here right now, is I'm able to use the particular keys for the particular food that I want. And now every time I press one of these keys, what I want to do is not just console log the item, but I want to say maybe if there's an item, then I might console.log ordering that particular item. So I know I put the name of the item in the first element of that thing. Else, so if there is no item with that index, then I might want to console log please try again. And I'm going to get rid of this console log key because I don't need to see the key that was pressed. So what I have right now is, when I run this, I have my options. I press 1, and it says ordering bacon. Press 5, and it says ordering water. If I press 0, it says ordering chili. And if I press J, please try again. Right? Please try again. Neat. And now, what I want to do is actually order, like begin processing this food, the particular element that had been ordered. So ordering that particular item, and then I might say order or create something like I'll say order. Oh, I had an order and prepare function in here. I didn't. What? I don't know how it autofilled. Okay. All right. Order and prepare the particular item. I want to order and prepare the particular item, and then after it's ready, I might want to do something like, here you go. Here's the food. So I'm going to go over to maybe somewhere up above and make myself order and prepare. This is going to be a function. What does this function need to receive? the item itself. And then what I'm going to do is I'm going to set a timeout for however long that item takes. So if this here, what I've highlighted up there, if that is an item, how long should I set this timeout for? For the second index of the array, right? So we're here, I'm going to go item and get the second index of the array. And what I'm going to do after I finish this is I might like console.log cooked, like ding, prepared, and then the item name. So this order and prepare, this is going to be dynamic, right? The set timeout will be different for every item, right? Sometimes it'll be 2 seconds, sometimes it'll be 1 if I ordered water, right? Other times if I order something more complicated like bacon, that's going to take 10 seconds. I'm going to run this now. I have these options. I'll do 2. And my spicy chili, yeah, because I did 2, yeah. Well, I could either go through and change all of these to thousands. I totally forgot about that. What could I do to this to make sure that it's always like in thousands? You can multiply it. Right? So now this way, I'll order a chili, which is 2 seconds. And after 2 seconds, it says, ding, prepared a spicy chili. And I could do a bunch of waters. I could do root beers. What else could I do? My kale smoothies. So if I do a kale smoothie, it's going to take quite a while. Whew, man, those kale smoothies. Hope it was worth it. 7 seconds. And what's fun is like I can just mash a bunch of this and watch this stuff eventually kind of come back. Right? It's being handled somewhere. Right? I could do as many of these as I want. Right? And Node will handle all that stuff for me. Yeah, it's very efficient. Look at all those kale smoothies coming back, all those bacons. And there we go. Like that's the basic idea. Now, you might not be making a restaurant simulator, but what you might be making is a program that needs to handle lots of users. Right? And for each of those users, something needs to happen. Right? You know, something I didn't do is, it's 11:54. I was thinking something that I could do was package up these foods into orders. And then you'd be able to see that like a full order would be able to, like, when it's finished, here's a full order. And some full orders might be finished before other ones. Does that sound confusing? Yeah. Like if I might be in line and I might order bacon and water. Right? Bacon and water. And somebody else might order 4 Big Macs. And so they're like separate orders. And I was thinking it might be neat to put that stuff into like arrays of their own. So they're like complete on their own or whatever. I don't think I'm going to do that right now. But if you wanted to expand past this example here, that might be something interesting to think about. It's like, how do you queue up stuff and then maybe press enter to submit an order, right? Stuff like that. Like I said, the thing that I built here is kind of stretch, right? Really what we're doing here is we're working around with like a bunch of input, right? Key input, like you're just going to have to play around with it a lot to get comfortable with it. And we played around a lot with like callbacks and set timeouts and stuff. There are a couple examples that I'm going to put in the lecture notes that I didn't show during our demo today. Maybe take some time to take a look at them and run them, or just give them a skim and see what they are. Don't feel worried if you don't like immediately understand this stuff. Async is arguably the most confusing thing for me when it comes to JavaScript. Right? And it takes a while to get comfortable with it. You kind of like Cindy, I don't know if it was with you. I showed there's the marbles in a funnel. Like, in general, when I'm learning something, especially in JavaScript, I feel very much like this. Like, okay, this is a terrible video, but like, where like, the marbles will get like closer and closer to the hole, and then they'll get further away, right? So, but eventually you'll fall in. Like, eventually you'll get it. Just give it some time. It being 11:56, I think there's one kind of quote to sum up what callbacks are for. Callbacks are very similar to pressure cookers. You set them, and then what do? You forget them. You set the stuff, and then you go do other stuff. Specifically, you set it and forget it. So I don't know if any of you ever seen this before, but
It's easy, folks. So simple. Isn't you guys? Isn't it simple?
it's just so simple.
I'll put the lid
Yeah.
on.
Put the lid on.
This is kind of nice.
Yeah.
There it goes.
He's making a callback right now.
This over, get this chicken over, this chicken over, and this chicken over. And I'll just walk over here.
Right.
I'll put it in this new Pro model. I'll slide
That's me putting the callback into the function.
all the instructional material. Just
And that's what you do. You set it and you forget it. Well, let's hear that again.
instructional material. You just
That's it. I don't know if that helps you at all. But yeah. Cool. We covered a lot of stuff. Take your time to go through it. Callbacks are going to make sense in some time. Any questions?
Are we going to be getting the notes for this?
Yeah, you're going to get notes for this in like a minute. I'll compile them and send them over. Also, I don't know if you all do this, but take a look at like other instructors' notes. At this point, like you've had a couple different instructors. You may go like, oh man, that Nima guy, he's so handsome, but he's not a good instructor. Like, then you might want to go look at somebody else's stuff. Or it might be neat to go just check out to see like Travis puts a lot of pretty pictures in his notes. Right? I don't put pictures. You can go check out his notes as well. Cool. Do you know where to find those notes? Yeah, like when you're looking at the particular lecture, you scroll down to the bottom, you see everybody's notes from like years and years ago for every topic. Cool. Have a great rest of the day. Notes will be out real soon. And thanks for participating. That's very nice. Yeah. Have a great day.